Okay, sorry about that. I had a meeting to go to. So the first thing we did was we took functions and we graphed the absolute value of those functions. And the idea is you graph the original function, and then any part that is negative underneath the x-axis, you just reflect over the x-axis, and this is the resulting function. And two things I pointed out once again was the original graph that remained above the axis had the original function. We can see here it was y equals 2x plus 3. This left branch, we're still x squared plus 3x minus 10. But we saw the reflected part was actually the negation of the function. Okay, so the next idea in the unit is this idea of taking the absolute value of every x value. So once again, you're plugging in x values and you're getting an output. Well, we can kind of figure this out on our own because we know that any negative number we put in there certainly takes the identity of the positive output. So what's going to happen is the graph is going to start, it's going to look basically like the graph to the right of the y-axis was simply reflected over the y-axis. If you think about it, -1 is not the same thing as 1. -2 is the same thing as 2. -3 is the same thing as 3. Let's take a look at that. So we can pick any function. Well, you know what? Yeah. So let's take a quadratic where you can see more clearly. Because reflecting a line over the y-axis, so let's see. So let's take let's look at the graph of f of x is equal to x times x minus 2. And we're asked to graph, you're asked to graph f of the absolute value or the modulus of x. Okay, well, you can see what's going on in your GDC. You can see what's going on. But let's just take a look at the graph. So first thing you're going to do, step 1, graph the original graph. Now, this is in the book, and it's created so you can clearly see where the zeros are. We know that 1 is the axis of symmetry, and so it's 1 times -1, so it's down here. Yeah, perfect. And so it looks something like this. And the idea is this whole right part is not going to be reflected over the left part. So what you're going to do is kind of erase the left part, and you're going to reflect it over the y-axis so it looks like this. So let me use pink. So the new graph looks like this. And this is the graph f of absolute value of x. So once again, step 1, graph, sketch f of x. Step 2, reflect, or you know what, sketch f of x for x is greater than or equal to 0, and then reflect over the y-axis. As I said before, if you think about it, all the negative numbers take on the positive numbers, and so this is the reflection. This is the graph. Okay, now you're probably just going to be asked to, just sketch this, but the real problems come with the absolute value problem. So let's go over some of those. So, solving equations. And once again, you can always check this out in your GDC. Let's see. So, solving equations. Solving equations of absolute value of x. So, let's just start with the basics. The absolute value of x minus 2 equals 9. Well, we know that absolute value means distance, so the distance from 2 is 9. the distance from 2 is 9. That's what this equation reads. Well, we can visually see what's happening. The 2 is the center. You go 9 to the right, 9 to the left. We would expect the answer to be 11 and 11 and negative 7. Let's do that algebraically. We know we set x minus 2 equal to 9, and x minus 2 equals negative 9. So we have x equals 11, x equals negative 7. And we can visually see that on a number line. When 2 is the center, and the idea is it's 9 to the right, which just gives us 11, and 9 to the left, which gives us negative 7. Okay. The next equation is an inequality. So once again, yes, these are basics. Let's go to the next one. Absolute value inequality. These are my favorite. I love these. Next. Let's see. The absolute value of 2x plus 1 is less than or equal to 5. So, I call this dog on a leash. So when you have the distance is less than 5, I want you to imagine like your dog's running around and you stick like his leash like in a stake in the ground. And he can only go like 5 this way or 5 that way. That's how I call this dog on a leash. So what we're going to do is we're going to set this up algebraically is negative 5 is less than 2x plus 1 is less than 5. Subtract 1 from both sides. And then divide everything by 2. Because we're not dividing by a negative number, we don't have to worry about flipping the inequalities. And so we have negative 3 is less than x is less than 2. Now, this is a compound inequality. This is a little outside the unit right now. This is x is greater than negative 3 and x is less than 2. Both conditions must be met, and we can see from our graph visually, because I called it dog on a leash, it's between negative 3 and 2. Open circle, that's the idea. The dog can only go like 3 to like South Street 3 and North Street 2. Something like that. Let's do the other absolute inequality, which is greater than. Okay. So we have, let me check that around. I'm sorry, and I call this dog on a leash. Dog on a leash. How are we doing for time? Nice. So we have the absolute value of 3x plus 4 is greater than 8. I call that stay away. That's saying stay away from whatever the center is. So let's solve this. Nice. So we have negative 8 is greater than 3x plus 2, which is itself greater than 8. I always find this a little weird, but the kids are fine with it. If you write this as a compound, notice this as 3x plus 4 is less than negative 8, or 3x plus 4 is greater than 8. So the idea is, it's like stay away. It's saying that there's two values here. You have to be less than negative 8 or greater than 8. Imagine like there's an oil spill or something like that, or like when they're spraying around Baridara, you stay away. So let's figure out what these points are. So we have, So we have, let's see, 3x is less than negative 12, x is less than negative 4, or we have 3x is greater than 4, x is greater than 4 over 3. And that's the idea. Either open circle because it's just less than or greater than, or closed circle if it's greater than or equal to. But either way, this is the idea, and I call this stay away. stay away. The second you see absolute value greater than a number, stay away. Absolute value less than a number, dog on a leash. And absolute value equals to a number, specific locations at a specific distance. Good. Now let's talk about equations. So we look at this, we kind of did discuss exactly the absolute value. So let's let's take a little detour. Let's take a look at y equals the absolute value of x. Well, we know what this function looks like. It's kind of like, So we know what this looks like. It actually is the way we describe the absolute value, which is a piecewise function that it's x when x is greater than or equal to 0. It's negative x when x is less than 0. And that kind of makes sense. It's not the best graph, but this is the absolute value. And then I could draw, y equals 2 absolute value of 3x minus 4 plus 5. You have technology, but you might be asked to tell me what the transformation is. What do you think the transformation is? Well, the parent is the absolute value. What's going on first? Take a second to do this. Okay, well, I see that it's a horizontal shift of 4 to the right. Then I see a horizontal stretch by a factor of what? 1/3. Remember, that's the weird one. Then I see a vertical stretch by a factor of 2. And then I see a vertical shift up 5. So you can see here in G, let's see, we can kind of draw it ourselves. All right? We can draw this ourselves. So let's see, horizontal 4 to the right, stretch of 1/3. Right? So what does that mean, a stretch of 1/3? And then even more, and then up 5. So this kind of is this is the new function. Once again, you can see this in your graphic calculator, and IB most probably is just going to ask for these specific descriptions of the transformation. Now, I bring up the graph because they're going to ask you to solve, the book is going to ask you to solve, this might show up, they're going to ask you to solve absolute value equations with absolute values on both sides. And so, a lot of kids, they do the algebra, they're like, tons of algebra. I'm like, wait a minute, let's think about this for a second. Let's take a look at the equation. The absolute value of x plus 1 is equal to the absolute value of 2x minus 1. So a lot of kids are like, well, just set a bunch of equations up. My suggestion is get a sketch down. Get a sketch down for these. So let's take our pencils out. Let's get a sketch down. That's my advice. So let's take a look at the first one. The absolute value of x plus 1. Well, I know that it's the parent function, but it's 1 to the left. Okay? That's the first one. Let's do the second one in pink. 2x minus 1. I know that it's the parent function. It's 1 to the right? And it's a stretch. So it's 1 to the right and a stretch of 2. Now the question is, what is the y-intercept? Well, it's also this. But it's a little skinnier here, so I know it goes like that. Okay? And so I can visually see what's going on here. I can visually see the equations I need to solve. Because before, if you recall, I listed the actual equations here. I wrote that this is actually x plus 1. Right? I wrote that this equation is actually 2x minus 1. And I wrote that this equation here is negative 2x plus 1. So, and ignoring the fact that we already know this first intersection is x equals 0, let's just solve this algebraically. I visually know that this intersection will be solved by the equation negative 2x plus 1 is equal to x plus 1, and I know that this intersection here will be solved by the equation 2x minus 1 is equal to x plus 1. So once again, once you have a visual and you know which equation to set it to each other, a lot of kids, they like run through all the combinations. I'm like, no. So we see here, we have negative 2x minus 1 equals x plus 1. We have negative Where did I make a mistake? Find the mistake. Sorry, okay. Minus, here we go. So, it's minus 2x plus 1. Sorry, I apologize. Negative 2x plus 1, negative 3x equals 0, x equals 0, nice. It's clear that's the answer. And the other equation, let's see what this ends up being. X equals 2, nice. So the solutions are x equals 2, x equals 0. Let's try another one. How about here's a good one. The next one is absolute values. Get a picture down. Once again, I'm all about the picture. Don't leave these in your head because they'll look weird. So the next one is the absolute value of 2x minus 3 is greater than, let me use pink, is greater than x plus 4. The absolute value of x plus 4. Okay, let's get a picture down. So, let's get a picture down. So let's make my graph. First is the black graph. 2x minus 3. I know it's the absolute value. I know that it's 3 to the right. And I know it's kind of like a little skinny. I know that it's skinnier, and I know that the y-intercept is negative 3. No, I'm sorry, when x equals 0, y equals 3. So it kind of looks like this. And I know that x equals 4, it's 4 to the right. It kind of looks like this. Oh, sorry, let me do the thing. I know, once again, it's not the best sketch. I know it starts over here at 4 to the left. It passes above this. But I know that, forgive me, please forgive me. I know that it's, well, you know what? Sorry. I know, anyway, we know it looks something like this, and that this line, it kind of looks like, sorry. Okay, the absolute value of 2x plus 3 is greater than the absolute value of x plus 4. So let's get the graph down. We know that this 3 to the left is skinnier, so it kind of looks like this. We also know there, and this is the absolute value of 2x plus 3. And then we look at the absolute value of x plus 4. So we know it starts here, it goes above, but then it kind of like because this is 2x plus 3 and the slope is steeper, it's going to eventually get higher than this branch of x plus 4. Let me do this in pink. So this is 0, 4. This is negative 4, 0. This is 0, 4, but then it kind of like, it gets, this is the graph we have. So, so the black is, this part is the absolute value of 2x plus 3. This branch over here is negative 2x plus 3. This branch over here is x plus 4. This branch over here is negative x plus 4. So the idea is so we can clearly see that 2x plus 3 So we're going to look. We're going to look at this last problem. The absolute value of 2x plus 3 is less than x plus 4. Okay. So let's take a look at this. We have the graph. We have our graph here. So we have 2x plus 3. I'm going to take this on the side, 2x plus 3. I know that it kind of looks like this, where this is 0, 3, and this is, this point right here is negative 1.50. But I know that because of the absolute value, it's getting flipped up. So this point is 0, 3, and this point is negative 1.50. So it kind of looks like this, kind of looks like this. Okay. Now this branch is 2x plus 3, and this branch over here is negative 2x plus 3. Good. Now let's graph x plus 4. I know that x plus 4 on my graph, once again, it looks something like this. Okay, so I know that the point here is negative 4, 0. I know this point here is 0, 4, but I know that this part here gets reflected with the x-axis. Okay, let's do this in pink. So let's say I have this point over here, negative 4, 0. I have this point here, 0, 4, and it kind of looks something like this. Doesn't look like how it looks in the technology, but we know a couple of things. I know that this right branch of 2x plus 3, the slope is increasing faster than this right pink branch of x plus 4. So I know the black line is going to eventually be above it. Same thing here. This black line is always above the pink line. Now the question is, when is the black? When is 2x plus 3 less than x plus 4? Well, it's between these 2 points. Because you can see the pink line is above the black. So I need to find those 2 points. The question is, what equations am I going to use? Well, let's figure this out. What I didn't write was the pink branches. This pink branch is x plus 4. This pink branch, is negative x minus 4. Now that's fine. I don't need that pink branch. The 2 equations I'm going to solve. So let's see. The first point I'm going to use negative 2x plus 3 equals x plus 4 to solve that one. Then I'm going to use 2x plus 3 equals x plus 4 to solve that equation. Some of you are saying, why can't you just take x plus 4 and set it equal to the positive negative? If you can figure that, that's fine. Once again, I like drawing pictures. So we have negative 2x minus 3 equals x plus 4. Negative 3x equals 7. X equals negative 7 over 3. And then we have x equals 1. Nice. Complete all the homework assignments at the end of 6D.